Chapter 10, section 10.1 through 10.5, Math 103. I took this page from 475 of your textbook. And here there is an explanation about what the hypothesis test is. Hypothesis test use the sample data to choose between two competing hypotheses about the population characteristics. So here, in a hypothesis testing situation, you want to know if the data provides support for a claim about the population character. For example, suppose a particular community college claimed that majority of students completing associate degree transfer to 4 years college, majority. So it's like P is greater than 50%. To determine if you should believe this claim, you might begin by selecting random sample of 100 graduate of this community college. First of all, your sample must be random, and you always take large samples. Each graduate could be asked if he or she transferred to 4 years college. You would then want to determine if the sample data provide convincing evidence in support of this 50%. Where P is what population proportion of graduates who transfer to 4 years college. These hypotheses state that population proportion is greater than 50%. What null hypothesis is always opposite of this, and it takes also the equality sign. So what is opposite of greater is less or equal. Hypothesis of 50% say that majority of graduates transfer 4 years college, and hypothesis of P less or equal say that proportion of graduates who transfer is less or equal to 0.50%. And another example here is in criminal trial is a familiar situation in which choice between two contradictory claims must be made. A person accused of crime must be judged either guilty or not guilty. Individual on trial is initially presumed not guilty. So only a strong evidence to the contrary causes not guilty verdicts. So here you have two types of hypotheses. One, they call it null hypothesis, which is denoted by HO or H0, is a claim about the population characteristic that is initially true. Assume initially is true. Alternative hypothesis, which is HA, is competing claim. In carry on a test of HO versus HI, the null hypothesis HO is rejected in favor of alternative hypothesis HO, only if the data provide convincing evidence that HO is false. So to prove this alternative hypothesis is correct, you have to come up with a convincing data by taking a sample and prove your claim. So HA or alternative hypothesis is always take one of this symbol, is either greater, less, or not equal. But remember, alternative hypothesis or HA does not take equal sign. HO is, or H0 is the only one who take the equal sign. Now, I put a lecture note from one of our professors, this is Powell, and it's a good notes about population proportions. And these are examples. And 1,385 women were sent 19 question survey and 561 returned. 229 said they would like to choose the sex of the future child. Out of these 229, 140 said girls. So what's the proportion of the girls on this sample? 140 over 229 or 0.611. Which is consistent with population proportions here. So here, so it could be the proportions of HO. It just showed that HO always take the equality sign, and HO, it could be greater sign, less, or not equal. Suppose a particular community college claim majority of students completing associate degree. So proportion is greater than 50%. To test the claim, this is your alternative hypothesis, and your HO has to take equality sign. So here, what is your HO and H1, or H0 and H1? H1 is the claim, and HO always take equality sign, or is opposite of that. So if it's greater, HO can be equal or less. Again, remember, HO always take equality sign. You cannot put equality sign for alternate hypothesis. We always assume that HO is true, unless we convince otherwise. So here they explain about these two, HO and H1, which one is alternative hypothesis, null hypothesis. These are different scenarios. You see that HO can take equal sign. Alternative hypothesis can be one of these three, or these. And alternative hypothesis cannot take the equal sign. These are different examples. What is the claim? More than 1 in 4 young adults live with their parents. This is their claim. 25% more live with their parents. So proportion alternative hypothesis is greater than. What is the opposite of that? Equal. Here, fewer than, so it would be less. Fewer than 10%. Fewer than 10% means it's less. What is the opposite? Equal. HO. Different. Proportion of broad M and M different, not equal. This is your alternate hypothesis. What's the opposite? Equal. Now, you need to remember that here, they want to know which one of these not legitimate and explain why it's not correct. Well, why this one is not correct? Because alternate hypothesis cannot take equal sign, so this is not correct. And this one, P hat is less. We don't talk about P hat, is always proportion of population, not the P hat. This one is correct. Alternate hypothesis not equal. What is opposite? Equal. These two numbers must always be equal. So this is not correct. Again, this one, HA cannot take equal sign. These are more examples here that you could read. So we also have two types of error. They call it type 1 error and type 2 error. And this one, the claim is proportion exceed the overall industry rate. So this is what their claim is. Opposite is not, is less or equal. So Bureau of Transportation report that 65.3% of all domestic passenger flights arrive on time. And airline with a poor on-time record decide to offer employee bonus, and they're saying they exceed the overall industry. This is what they claim. So although we know this is true, you know, HO is true, you claim that it's false. Airline believe its plane exceed the industry on-time flight arrival procedure, even though they do not. So this is type 1 error. Type 1 error is that you reject the true HO. Type 2 error is your HO is false, but you accept it. And this is the second example. So they are saying the ideal test is that both are always 0. We don't want to have type 1 and type 2 error. For type 1, for significance level, we use alpha, and beta is for type 2. So go through the example, you understand this better. Type 1 error has more serious consequence. Use a small alpha like 0.01. Type 2 error has more serious consequence. Use a larger alpha. Now, when we take a sample, mean of the sample and or mean of proportion of sample is always equal to proportion of populations. How do you find the standard error, or how do you find standard deviations? Is this part. And you want to make sure n is always large. If n is large number, when you take a sample, if it's a large sample, then distribution is normal. This is a good example. In 2006, Associated Press survey was conducted to investigate how people use nutritional information. Interview conducted with 1,003 randomly selected at all. So n is 1,003. And question number 1, when purchasing packaged food, how often do you check nutritional labeling? And then how often, question number 2, how often do you purchase food that is bad for you? Okay, so it was reported that 582 reported frequently to the questions about checking label. 441 responded very often. So what is your HO and H1? We claim that proportion is greater than 50%. And we have to prove otherwise, which is equal. P hat is always equal to P of proportions. So that is 0.50%. To find standard error, we are using this formula. And sampling distribution in 1003 is the large sample. Now we also have z-statistic. Z-statistic help us to find the area for our sample. So z is p hat minus p. P hat is proportion of the samples. When you take the samples, p hat is that. So when we take a sample, our sample was 58%. 582 out of 1,003. 582 out of 1,003, when you calculate that, so p hat is x over n. 582 out of 1,003. So that helps us to find p hat. P is the original claim, which was 50%. And the bottom is the standard deviation, which is this formula. So you put that, you find the value of z. Now you want to calculate the area of this z. And so if you're thinking of, if this is the value of z of 0, 1, 2, 3, Greater than 5 means basically you don't have any area. Area to the right of this, if this is z equal 5, area to the right of z equal 5 is almost 0. So if your alpha, if the area that you calculate based on this is less than alpha, then you reject the HO. What I did here is I'll show you how to use the calculator for that. So you reject null hypothesis if P of value is less than alpha. What is P value? Is the number that you find through the calculator. I'll show you here. Stat, test. You click on number 5, which is proportion Z test. The P proportion of population is 0.50, which is the original one. And X is 582. We have this X 582 here. And the symbol that you pick on the calculator is always a symbol of HA. This is always for alternate hypothesis. Okay, that's where we use the symbol. So this is the result. This p-value is very, very small number, almost 0. That's the area for this type of Z. Okay, so if you are thinking of Z, the mean is always 0, and the numbers are 1, 2, 3. So let's say if I want to find the probability of Z greater than 2. Z greater than 2 means, probability of Z greater than 2 means this area. What is the probability of Z greater than 1.3? Is this one. What's the probability of Z is greater than 5? So 5 is a point here somewhere, right? So basically, you don't have any more area here. That's the p-value. P-value is area of that Z of statistic. This Z that you find through the formula, which is p hat minus p over p times 1 minus p and n. When you find this p through the calculator, you find the area for this Z. That area is your p-value. We normally give you the alpha in the problem. Let's say alpha is 0.05. You always compare this p-value with this alpha. If this p-value is less than this alpha, which is the case here because it's 0, then you reject HO. So here is right here. This is important to understand. HO is rejected if the p-value is less than alpha. So when you find a p-value from the calculator, if it's less than the alpha that normally given in the problem, which is basically 5%, then you reject HO. If not, you do not reject HO. So this test statistic, this formula will give you the Z value. Then you could use your calculator or through the table and find the area for this Z. So these are some of the stuff that you could study yourself. Here is different explanations. And when you do the problems, alternate hypothesis symbol always determine the area. Okay, let's say our area. Let's think of another example. Let's say our HO and H1. Our H1 is P greater than okay, P 0.3, and HO is P is not. If it's symbol of HA, if a symbol of alternate hypothesis is greater, then your graph is the right tails. This is the area that you find for the p-value. Another example, let's say your HA is p less than 0.52, and H1 is always equal or opposite. HA determined area of your graph is less than 0.42. Okay, so that means is a left tail because it's left. And not equal to 0.17. Let's say your alternate hypothesis is not equal. In that case, you have two tails. So when you use your calculator, calculator asks you about any of this, okay? So HA determine your graph. If it's greater, it means you have right tails. If it's less, you have left tail. If it's not equal, there are two tails. So in this example, calculator would ask you which symbol do we use. You put greater. Why? Because that is the symbol for HA. See, again, this is z equal to 4, and for z equal 4, the area is almost 0 again. If the p-value is less than alpha, see, alpha is 5%. And anytime you want to find this solution, first you have to make sure the condition of normality is working. This is when distribution is normal. In order to do that, you want to make sure that n times p and n times 1 minus p is always greater than 10. These are two conditions that need to be met. Like in this problem, so I use a calculator here. See, again, I'll put the greater than sign here. All right, so most of this homework, the first few section is all multiple choice, so you could go through all this. I don't want to spend time on these. And I guess I'll just show you one example, which is, this is explanation of type 1 and type 2 error. This problem is number 3. So what is type 2 error is you accept HO is not, HO is false, but you accept it. Type 1 is HO is true, but you reject it. You reject the true HO is type 1. Type 2 is you do not reject, you accept HO, which actually is false. This is the difference between type 1 and type 2. And this example might explain that to you. This is another example for type 1 and type 2. See, type 2 error, accept false HO. And I put for sections, for the last section, I'll put a complete example. If you understand example, okay, I'm sorry if I turn the pages very quick. If I put a copy of example 10.10, which explain what the HO is, what HR is, proportion of samples. If you follow these, which is show you step by step, then you should be able to do example in the book. See, this is very similar we had on the power wave lectures. And then I did, these examples are all following that. And I did one for number 2. I did it here so you could actually see it. And I'll show you how to use the calculator to find the area to the right.